And a big g'day to everybody up there at Kerrang. Today at the workshop, Graeme Anderson here, Climate Specialist with Agriculture Victoria in Geelong. I'm really sorry I can't be there in person today, but I have put together a few slides which is hopefully going to make a bit of sense about the weather and seasons in your district. So I'd just like to point out our seasonal risk team. Some of you might know some of the products. We've got the break newsletter Dale Gray puts together and soil moisture probe stuff that Dale Boyd does. We also run a whole bunch of regular webinars on climate. We probably speak at 140 forums a year. So a lot going on in that space. But if you want to see some of those products and learn a bit more about some of the other web tools we've got and posters, just head to that website. So first up, I'd just like to give a plug to the Climate App tool. It's a really useful tool for farmers. It's developed by the Managing Climate Variability Program, and you can see all of these dots here are long-term rainfall records. So you can find one that's closest to your farm. I've just picked Kerrang, Merrin Downs here, and you can do things like how's the season progressing. I've just done it from the start of January last year. This blue line is the long-term average. All of these years are individual years, and the red line is what's happened in the sort of last 13, 14 months. So it's a great little tool to keep track of what's how the season's progressing. And also with that tool, you can do other things like how often do we receive more than 50 mil of rain over a 2-week period in that record from 1st of March to 30th of May. So it helps just check your history, and often we're anticipating good autumn breaks and all of that sort of thing, but there's nothing like understanding, well, what's happened here in the past, and that climate tool is a really good one to have a look at. So just a bit of a review. 2019 was pretty dry, and what was probably most extraordinary, this is wide areas of where it was average. This is where it was decile 10 or wettest 10% of years. Decile 1 is where it's the equivalent of the driest 10% of years and driest on record. So for all of the dry seasons we've had, you can see some large areas of Australia that had their driest year on record. So that's why there was no shortage of heat and dry air floating around the place last spring. We'll talk a little bit about why that unfolded. So a long-term rainfall record here from Kerrang. This is goes back to 1881 back here. This is millimetres up the side, 200 mil, 300, 400, 500, 600, and you can see the long-term average is 372 mils, but some years it's over 600 and some years it barely makes 200. So you can see there's a lot of variability in the system, and you can see these last 2 years a bit drier. Now both those years were years when the Indian Ocean dipole was in its dry phase, so we'll talk a bit about that. You can see 2016 was when the Indian Ocean was in its wetter phase, and 2010-11 we'll talk about what was behind those wetter years. We had La Nina and Indian Ocean dipole both on their wet phases. So lots of variability in there. Some runs of drier years in the past, a lot of variability, probably wetter since the 50s, and we'll talk about what's driving some of that. Here's the same record, but we've just taken out the summer season, autumn, winter and spring. So again, you see lots of variability there. One thing we'll probably notice in the last 20 years, autumns are a little bit more hit and miss. So perhaps some of the winters a bit drier, and I guess the last 10 years, the springs, we haven't had too many. That 2016 spring was the only wet one we've had there in the last 10. Now, where does all of that moisture come from to make rain? So to make rain, you've got to have moisture, and this is one really key image. It's showing precipitable water across the planet, and what you'll notice is that most of that moisture is along the equator where the oceans are warmest. It's where a lot of the cloud is, and so seasonal forecasters watch these areas like a hawk in the Pacific Ocean and the oceans to our north and the Indian Ocean. And some years the pattern set up where all of that moisture is somewhere else on the planet, and it's hard to get that moisture feeding into weather patterns, and then some years it's all sitting around it. So that's really at the heart of seasonal forecasting, is keeping tabs on where is most of the moisture lining up this year. This is a great little map. You can see here southeastern Australia, and here's Antarctica, but key drivers behind our wetter and drier years. So we've got the El Nino Southern Oscillation. Some years There's lots of moisture coming from that, and especially in La Nina years. So 2010 and 11 is a famous one with lots of moisture barreling into us. The Indian Ocean dipole, it also has wetter or drier years, and sometimes these two can team up. So 2010, 11, they were both in their wetter phase, and say 2015, they were both in their drier phase. So they can team up. And you can see these cold fronts whizzing around the Southern Ocean. That's driven by the southern annular mode. Really important triggers for rainfall in southern Australia. So you need a wetter years when we've got more moisture floating around our part of the world, but also plenty of triggers to make it fall out. So they're really they're the key drivers that a lot of the forecasts are tracking. Now here's a long-term rainfall record back to 1900 for Kerrang, but this is from a new local climate tool on the Forecast for Profit site. It's worth checking out. Basically, each of the years are color-coded depending on which climate driver was active in those years. And what's really interesting in that, in your district, just seeing in those years when there was a combined El Nino with a dry phase of the IOD, you can see they were the really driest years when both areas of moisture supply were knocked out. And you can see in years when the moisture supply was coming well from IOD negative in 2016 or the 2010 La Nina and IOD negative, they're those wetter years. And of course those last 2 years, the positive IODs when it's dry, you can see those two there. But a really good site to go and check out just to see how these things affect you in the past. And basically what seasonal forecasts are made of when you're trying to predict the future is what each of these drivers are up to in the months ahead. Yeah, so a key question is, well, how do these climate drivers affect our upper catchments, which are pretty important for irrigators? So when we head up at look at the Midda River in the upper catchments, and we're looking at that sort of August and November flows in catchments, and then we're looking at what's happened in the past when there's been El Nino years. Normally you expect a third of years to be in the red dry, a third are average, and a third are wetter, but you can really see how El Nino's doubles the chance of those low runoff years, and the same when the IOD is in its dry phase. And those higher runoff years increase chance of then when we've got either a La Nina happening or the Indian Ocean dipole in its wetter phase dragging in extra moisture. So there's probably an amplified influence of those climate drivers on your catchment. So that's why they're worth paying attention to. So there's a bit going on in the forecasting world. I'm just going to share a few products here, and this is about understanding seasonal forecasts. And there's a Forewarned Farm product which is working on better products for farmers. Now, I'll just talk about a little bit about interpreting seasonal forecasts. So here's the bureaus, and they've put out their now multi-week and seasonal forecast, which looks at, say, the next 3 months. And here and you'll see some of these maps. So I'll just talk a little bit about making sure we're understanding forecasts. So here's an example of the current forecast that the Bureau's got for the next 3 months, for March to May. This was issued on the 13th of February. You can see these sort of maps, and they give a probability of above or below the chance of exceeding median rainfall. So you can see here, looking at this area here, a 40% chance of exceeding median rainfall. So, but that's also meaning a 6% chance of less than average rainfall. But there's a little bit more devil in the details. So basically the same data runs. So imagine that if they've run the forecast, they've looked at sea surface temperatures and where the cloud is, and they've run the models for the next 3 months. And out of 100 model runs, this is sort of what's happening. This is sort of showing the spread of the model runs for March, April, May for somewhere like Shepparton, not too far away. So you can see that decile 1, 2, 21 of the models landed there, 33 of the models landed in decile 3, 4, 19 of the models landed in decile 5, 6, and only 10 of the models landed in decile 9, 10. So it sort of gives you an example. That's basically, it's the same forecast, but it's just a different way of explaining it. And so often even, and a key is sometimes you might see a forecast where it says 50% chance of above or below median. A lot of people say, oh, that just means average. Actually, it doesn't quite mean average. It means often that there's as much chance of decile 1 as there is of decile 10. So just important that when we're reading these seasonal forecasts, we understand what they are saying and what they're not. Just for comparison, if we look back at these forecasts in September 2019, there were 51% of the model runs were landing in decile 1, 2. So some years there's a much stronger signal than others. At the moment, it's all looking, it's a bit unpredictable what will happen, which is often the case in autumn. Now, for a one-stop shop of making sense of forecast, the Fast Break newsletter that Dale Gray puts out with AgVic is a ripper. Basically, each month he puts this out. He looks at not just the Bureau's seasonal outlook, but he looks at the outlooks from the US, the UK, Europe, Korea, Japan, all of their seasonal forecast models, and he puts them on this graph and basically looks at Victoria and says how many are thinking average, how many are thinking wetter, how many are thinking drier. So this is the current one he's just looked at. See, there's 8 there sitting on average and there's 4 there sitting on the drier side of the fence. So it's a really good simple way of getting a bit of a heads up of what's going. It's interesting, if you look at last spring, we actually had for a couple of the months all of the models that he looked at had us on the drier side of the fence. So some years is a much stronger signal than others. So what I've talked about is a lot of variability. Now I'm just going to cover, is there anything different to long-term natural variability? So this is a key one. This is a map of maps from 1910 through each decade of maximum temperature deciles, and the blue is cooler than average years, and the yellow is warmer than average years, and the dark orange warmest on record. So you can see a lot of variation there through the decades, but also you can see that, well, in the last couple of decades, things are really starting to warm up in that warming trend, and that's sort of been expected by a lot of the climate models, and it's to do with greenhouse gases trapping more heat. Basically, these days we're squeezing in an extra month of summer from a temperature point of view. So rainfall variability will continue, but really important to note that we're at the start of a trend where, you know, the summer season is getting bigger. Some of those summers will be wet, some will be dry, but it's that temperature thing that really is different to long-term variability. Yeah, and here you can see this is for southeast Australia, maximum temperatures for summer, for autumn, winter and spring. So they've all got increasing trends. There's still quite a bit of variability around there, and so milder winters can be probably helpful for pasture growth. But this one, you can see spring in the last 10 springs has been quite a few, between 1, 2 and almost 3 degrees warmer than average. So that's summer turning up a month earlier. So that's what's a bit different to just normal variability. Now, another thing that's a bit different is just the pressure pattern over southern Australia, this region here. So you can see since 1950 up to recently, pressure varies from one year to the next, which is variability. But what's been happening is we've been having an increasing pressure trend. And what that does is it just squeezes out the odd bit of rainfall in some of those years. Now, that's a trend that's expected to continue in future, which is why we're expecting to have some dry years thrown at us in future. And I would just like to have a bit of a chat about the difference between weather forecasts and seasonal forecasts and climate change projections, and where we're more confident and where we aren't. Weather forecasts basically go out to 8 to 10 days. They're called deterministic forecasts, and they'll predict what the weather's going to be like on a particular day, temperatures, you know, what rain you might expect, wind and all of that. So they're all good. Just be aware that there's different models, and sometimes for some weather events there's the models don't all agree, so sometimes that's important to know when they're more confident and when they're not, so to get more than one opinion. Also know that while they can forecast thunderstormy weather on a particular day, they've got no idea where actual individual storm cells might start. That only happens an hour or two before. So you know, sometimes with our rainfall we can get a lot in those thunderstorm events, but they're not quite as predictable a few days out. Important too, seasonal forecasts, what's sort of happening with them is, you know, depending on how oceans and cloud patterns are set up, they run the models for the next 3 months and they give you these probabilistic forecasts. No one actually knows what's going to happen, but sometimes those weather patterns can be really heavily skewed, especially in years when there's a really strong climate driver away. So some years seasonal forecasts offer a lot more value than other years. So, and if anyone's telling you they know what's going to happen in the next 3 months, then they're pulling your leg. So just be wary of that. Also, with climate change projections, there's a lot of confidence around those trends of increasing heat. There's an increasing temperature because there's increasing heat being trapped in our atmosphere, and that's 90% of that heat's going into oceans, so that's something we're going to see a lot more of. What happens is basically as things get hotter along the equator, we see a poleward shift of weather patterns. So for our part of the world, we see weather patterns sort of shifting south. So there's a high degree of confidence around that, but there's a lot of uncertainties, especially around how it will affect some of these key drivers of our variability. I'll also just point out too, there's this website, there's some good local climate guides that the Bureau of Meteorology just put out. They're little 4-page fact sheets on looking at weather in the last 30 years. So there's some I'd recommend them to have a look at, just to look at some of the local trends. So just some more resources and tools. Rob will point you to this one. Extension Oz got a really good website. And you'll see lots of stuff there, like the weekly irrigation requirements, all that stuff. You're probably already getting that, but just making sure you know about it. They're really good resources. So no matter what happens in the future, I mean, we've got seasonal variability and climate change in the mix, so that's going to give us plenty of challenges with dealing with a bit more variability and plus increasing incidence of drier and warmer. But I guess there's a lot of things that are in our favour, and this is a lot of the things that are being applied across farms in all districts. And we've got modern tech, R&D, genetics, innovations, all things that can really help us do things more efficiently and do them better than we have before. Also, there's been a heck of a lot of great work on improved on-farm and regional infrastructure around, water and fodder and how we better deal with that increasing variability. So there's plenty more work we'll be needing to do there. There's a lot of work we've got to do on biosecurity, and really important because that work enables us to keep access to global export markets. And while they're growing, the biosecurity is a really key platform for keeping them open. This is probably a really important one though, with the business volatility from year to year. It's not just the weather, but also with market volatility, that has a really big impact on businesses. So getting good skills and financial skills around how you handle that variability is really important. And often some of the most valuable things that are done on farms for setting them up for longer term future is around what happens in the good years and what you invest in that actually helps you ride out the tougher years better. A lot of great work happening with farm planning and setting up the health of our farms a lot better. And the important thing, which is why you're there today, is learning, sharing information with other people. Make sure you're tapping into good knowledge and turning up workshops like that. And they're all the things that help you make sense of a changing world and confidence to invest and make you better off in future. Anyway, I hope that has been useful. If you need any more information, just drop us an email or head to the website, and all the best for the rest of your workshop.
For us, I suppose, with a dairy background and perhaps aren't as familiar with some of the tools and the drivers, what sort of, do you have any suggestions to help us to be a bit better skilled at working out what's coming up weather-wise?
I guess, one of the main things with the cropping guys, what they've done really well is the variability and understanding how much of the soil profiles there. So rain in the bank has been really important. So that's some of that stuff with the deep soil moisture probes and stuff has been really handy. And it's been very interesting to know, especially some of that out of season rainfall, knowing how much you're starting off the year with in the 50 centimetres and below can really be useful, because it means that, even with a dry year, on top of that, you've got a chance of a crop getting its full bit. So that's measuring what's in that deeper profile is pretty handy. But then the forecast stuff, Rob, there's a few different tools. There's quite a lot of different forecast products that are good out to about 7 or 8 days. And I tend to look at more than one model, because some weather events keep the forecasters guessing. And probably half of the apps that farmers have on their phones and things these days, probably only half of them are from the Bureau, because there's good climate models from the European model and the US model, and so you're never quite sure which one you're using. So sometimes it's worth just comparing a few models, especially for a big rain event. And then I think the break's probably as good as anything. I really like what Dale does when Dale looks at the 12 global forecast models and looks at Victoria, just to get a bit of an idea of how many are lining up on the drier or wetter for our region of the world. And so last year, in about August, it was the first time we'd seen it in 12 years of the break that actually all 12 of the global models had our little corner of the world being drier. So that's a strong signal. Normally, if we see more than half the models starting to think it's drier or wetter, then we start paying a bit more attention to it. But it's probably, if you want a quick one-stop shop, that little table in the fast break is probably the best thing. And the bit is that no one actually knows what's going to happen in 3 months' time. So if you find anyone that's guaranteeing something that's going to happen, that you probably should file that under the astrology section of your office files, I reckon.
Thanks so much, Graeme.
Cool, have fun. Sorry couldn't be there in person, so good luck for the workshop.
Thank you, see ya.
See ya.